We can't see it, but we feel its effects. It impacts everything in the universe. It's gravity. Come down to Earth and learn more.
Gravity is the force of action between two objects, in this case, between the melons and the Earth.
In the late 1600s, Sir Isaac Newton saw an apple fall from a tree. That made him wonder if the force that made the apple fall was the same force that kept the planets in orbit around the sun. Newton changed the way we all look at gravity.
To talk about gravity, you first have to talk about mass and matter. Now, matter takes up space and has mass. And mass is a measurement of how much matter something has. The more something weighs, the more mass it has, and the more gravity pulls on it.
But the Earth's gravitational pull is strong because it has so much mass. The greater the mass of the object, the greater the force of gravity. Astronauts could bounce easily on the moon because the moon's gravity is less than the Earth's, because the moon has less mass than the Earth.
Does that mean I weigh a different amount on different planets?
Well, on Earth, suppose you weigh 100 pounds. If you were on the moon, you'd weigh about 17 pounds. But if you were on a bigger planet, say Jupiter, you'd weigh more than a whopping 236 pounds. And gravity's effect depends upon how close objects are to one another. The Earth's gravitational pull on, say, Pluto isn't very strong because Pluto is so far away. But the Earth's gravitational pull on the moon is great. The Earth's gravity keeps the moon in orbit.
So if Earth's gravity is so strong, how do astronauts get into space? And why do they just float there?
Astronauts can take off from the Earth because the thrust exerted by the power of the rocket is greater than the force of gravity pulling them down. But astronauts never travel beyond the Earth's gravitational pull, and they aren't actually really floating. They are, in fact, always falling toward Earth. But since they're also moving forward, they fall around the Earth in a circle or an orbit. To the astronauts, this constant state of falling just feels like floating. It's called a state of weightlessness, or zero gravity.
These Boise State University engineering students are flying in a special airplane that can create moments of weightlessness.
Zero G.
They're studying the effects of microgravity on the traction of different wheel tread designs on lunar soil. And they're also testing ways to find out how much water there is in the soil on the moon or other planets.
Best feeling in the world, man.
Gravity affects everything on Earth, including the Earth. Gravity from the moon pulls at our oceans, causing high tide and low tide. Gravity pulls water from the clouds, causing rain and snow. Gravity tugs at rocks, causing simple loose rocks to move or whole hillsides to slide down. Even stars and planets are formed when gravity pulls dust and other small particles together. So gravity is one of the fundamental forces in nature.
Oops.
You okay?
Yep. What goes up must come down. It's just gravity.
If you want to learn more about gravity and other scientific topics, check out the Science Trek website. You'll find it at idahoptv.org/sciencetrek.
Don't look at me.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho. By the Idaho National Laboratory, mentoring talent and finding solutions for energy and security challenges. By the Friends of Idaho Public Television and by the Corporation for Public Broadcasting.